So if we think of looking at this classroom from the top, so let's draw a system of axes. So let's say, let's call this is the x-axis, this is the y-axis. So I am standing over here right now. In front of me is the lectern. And we started with Elias over here. And he had to get to a place over there. And I asked Cabello to get Elias there using the fewest number of commands. And Cabello immediately said, okay, well, I can split this up into 2 commands, each containing actually 2 little bits of information. The first was, he told Elias, okay, walk straight. Now, from Elias's point of view, straight meant I have to walk in this direction, like so. Then he said, stop. Then he said, turn left, and then walk straight again for a certain amount. And Elias got his note. Right, so we can say, we can specify the position of an object, in this case that IOU for 1 chocolate that I wrote, in terms of 2 numbers. We can say Elias had to travel this far along the x-axis, so let's just call that x, and he had to travel this far along the y-axis if we started at his initial position. So we can say the position of this IOU that I place on the floor is specified by 2 numbers, x and y. And we always going to write it in this form, so x first, y first. And this means so much parallel to x, and that number means so much parallel to the y-axis. Right, so this is the first way in which we could describe the position of the IOU, and the fancy name for this is we call this a rectangular coordinate system. Right, so it makes pretty much sense. If we have to figure our way out in 2 dimensions, this is one way of doing it. We can say, well, let's choose 2 set of reference directions, in this case the x and the y-axis. And then we must just specify how far along one, how far along the other, and we can specify positions. Now the second one was a bit more subtle. So the second one that we had, again we had the class, so there's our x-axis, there's our y-axis, I'm over here, there is the lectern, and then we had Cabello. I hope I'm spelling your name correctly, sorry. K-A-B-E-L-O, so without the H, thanks. So we had Cabello over there, and Cabello was initially facing in that direction, and I placed his IOU for 1 chocolate right over there. And Elias combined the 2, but in essence what he had to do is he had to first tell Cabello, well, turn by, in this case it wasn't just 90 degrees, it was actually more like 135 degrees. But he had to also tell Cabello in what direction to turn. Now Cabello guessed in which direction to turn, but Elias could have told Cabello, from where you are standing, turn 150 degrees anti-clockwise or counterclockwise. So this means Cabello had to turn in that direction. So he turned around until he was facing in this direction. And then it was a mere matter of, okay, well, walk straight ahead now for that distance. So here it was, the bits of information to specify was, okay, walk in this, you're going to have to orient yourself so that you face in a certain direction, and then you walk straight in that direction until you are where you need to be. And this is what we call polar coordinates. Right, I'm just going to draw a picture that's a bit more mathematically rigorous, so without me, Cabello, Ilias, or any chocolate IOUs in the graph. So basically what we're after is in a system of axes, x and y, we've got a point of reference, our origin, and we want to be able to describe the position of this point. Now, in rectangular coordinates, we can simply say, well, let's say this point is, let's say it's 4 centimeters. If I take a line that makes an angle that's perpendicular to the x-axis down from that point, this distance is just 4 centimeters. And let's say that distance, if that makes a 90-degree angle, let's say that's 3 centimeters. So then we can say this point in rectangular coordinates we can say its position is specified by the coordinates x, which is 4, and y, which is 3, and it's all in centimeters. So that was Cabello guiding Ilias. That was rectangular coordinates. But we can also say, well, let's start, and if we start, say, from the positive x-axis, we must now rotate by a certain angle. Let's call that angle theta. It's just a Greek letter. After doing physics 1, you will be proficient in Greek. For some reason, we use a lot of Greek symbols. So we can say, well, start from the x-axis, go anti-clockwise and turn through this angle, and now you walk a certain distance. In this case, we're lucky that distance will just be 5. So we can say in polar coordinates, we can say the position of this point is defined by r, which is this distance, so how far away from origin it is, and an angle theta, which means if I start from the positive x-axis and I rotate counterclockwise, by how many degrees must I rotate? And this is then 5, and, well, we don't know this angle yet, we can measure it, but it will be some value in degrees. So we've got two ways in which we can define the position of a point. And each of them actually require 4 little bits of information. So in rectangular coordinates, the information they require is we must agree on the directions of our x-axis plus our y-axis. So we must set that up beforehand. So we must decide, okay, we will have an x and a y-axis. This is how it's going to look. So that's 2 bits of information. These 2 reference directions we set up, an x and a y. Then we also need how far along x and how far along y. So 4 bits of information, 2 directions that we have to set up beforehand. So we must agree on what's going to be in front, what's going to be to the right, what's going to be to the left, what's going to be behind. And then we need to specify how far in each of these directions you must travel, one after the other, to get to the point specified. For polar coordinates, it's a bit more subtle. Here we just need to agree on one direction. In this case, the x-axis, because that's the point or the line from which we are going to measure these angles. But then we must also actually agree on how to measure our angle. So we can choose to measure, once we've got our x-axis, we can decide to measure our angle anti-clockwise or clockwise. So we must agree on, are we always going to measure our angles counterclockwise, or are we going to agree to always measure our angles clockwise? But once we've agreed on that, in this case we've agreed to measure angles counterclockwise, then we just need two magnitudes. So then the only information we need is how large is theta and how large is r. So how large is that angle and how far away in this direction must I travel? So anyway, if you want to specify a position in 2 dimensions, you need to specify 4 bits of information. So your reference directions, how far you go along each direction, or alternatively then, 1 reference direction and a convention for in which direction you're going to measure angles, and then again 2 magnitudes. So if you have that, you can specify any point in 2 dimensions.